Hello everyone. Welcome to my session today this morning. Thanks for coming. My name is Rachit Arora, and I am going to present today on topic like why Kubernetes as a cluster or a container orchestrator is a right choice for running the Spark workloads. So before I start, a little about myself. I am an advisory software engineer at IBM India Software Labs, and I work out of a Bangalore Software Labs. So I landed Berlin on Tuesday morning, and this is my second visit to Berlin. I was here in Berlin in early March this year, and it was around some microservices and serverless conference. And that time of the Berlin, it was like more cold, snow. This time it's like more pleasant and more comfortable. I roamed around the city my last visit, and it's really beautiful historical monuments. I learned a lot about Berlin. Yeah. So, and I am basically from cloud team in IBM. We provide services on IBM Cloud, and currently I am working on where we are building a service for which provides managed cluster offerings on Apache Hadoop and Apache Spark as a service to our customers. We use Hortonworks data platform as our platform, so you get the same experience of using on-prem and on cloud. And I am basically a fan of Docker containers or container technology and the Kubernetes. We have been using containers and Kubernetes from past 4.5 years for building our offerings. And I'm a very frequent conference traveler. I speak at various conferences in domain of containers mainly and Kubernetes. And this is my first conference where I'm talking on a Spark configuration, Spark conference. And I'm also writing a book on Hadoop and its ecosystem, which will be publishing by end of this year. So this book is mainly from the academic side of it, who wants to get started on Hadoop and its related ecosystem, and around the cloud adoption also. And I'm a cricket fan, which you can expect from being an Indian. So I like cricket, and I enjoy my food also. So before I start, I would just like to have some show of hands. How many of you are from Spark background or know Spark? Quite a few. And how many of you know Kubernetes and containers? Oh, good. So this will be a right set of audience for me. So before I start, just for some who don't know Spark. So Spark is an open source, scalable, in-memory engine for running your analytical applications. You can think of Spark as an in-memory layer which sits on top of your data sources, and it pulls all the data in memory and then run your analytical workload parallelly across the nodes in your cluster. So Spark comes with a core engine which provides you with the capabilities of creating your RDDs, scheduling your I/O, and it comes with a lot of pre-built algorithms on machine learning and data graph side of it, which are written specifically to be executed in parallel and in memory. So it also provides a SQL interface for you, and as well as the streaming analytic capabilities, so that you can write your applications in the language of your choice, like Java, Scala, R, or Python. Okay, so you can run Spark on various cluster managers. So Spark work with a cluster manager to get the executors it needs to run those workloads. So you can run Spark on Yarn, which is a very good production grade cluster manager, or you can choose it to run on Mesos, which is more on the mature side of the as a cluster manager choice. Or you can run it on your standalone scheduler, or even on the very newly introduced Kubernetes as a cluster manager for Spark. So this has been released in 2.3, Spark 2.3, Kubernetes for support for Kubernetes running as the cluster manager for Spark. So this is how a typical big data pipeline looks like. Many of you would be familiar with this. Yeah. So you need to make sure that when you run your big data application, you do it in a secure environment. All your endpoints are encrypted. You have proper encryption story for your data at rest and data in motion. And then you have some catalog options so that you can have data governance built around it, like somebody managing like what kind of access you want to give to a user on your data. And typically, you will have data ingestion from many sources, like you will be feeding it from some IoT devices or some log analysis or from various kind of sources. And you could choose to store the data in something like an object store after ingestion or move along with the pipeline. And at this moment, there comes a role of a data engineer whose responsibility is to basically capture that data from multiple sources and make sure that data is in the right format and is ready to run in ready for analytical jobs. Then comes the role of a data scientist who consumes that data which is prepared by a data engineer and governed by somebody that they have the right access to use that data, to work with tools like machine learning algorithms or work with Jupyter notebooks to build the predictive models or train the models and come up with the analytical outputs. And then those analytical outputs are consumed by application developer to build some applications around it. He could build some chatbots, which is talking to your customers and building some insights. He could use it in some BI tools for building dashboards and get more insights out of your data. So this is the typical big data application pipeline which we see people follow or to build their applications. So let's go into the shoes of a data scientist more and understand what a data scientist is trying to do and what they are trying to build. So as a data scientist, if I'm a data scientist, I want to run analytical applications. I want to do social media analytics. I want to do text analytics. I basically want to work with a notebook interface or a programmatic interface where I could run my R jobs or my Spark R scripts or Python scripts or my Spark jobs on a runtime. And I basically want to work on analytical jobs, and at the same moment, I also want to view the performance of those Spark applications I'm submitting through a history server so that I can improve on my jobs. And I also want to see the Spark application UI to see, better monitor the applications. So if you are a data scientist and if you need to do this on on-prem system, what do you need? So you will basically first need to acquire a bunch of hardware and assemble them right, get the networking done. So typically you will have network setups done for your private network where all the nodes will talk to each other on that network. And then you will need some public network governed by some firewall policies to access those clusters in your data center. And then you will also need some management network for the upgrade scenarios or if you want to patch your machines. So once you have your machine setup done, you will start preparing those machines. Like you will start installing the prereq softwares required for installing Spark or required for installing Hadoop on top of it. And then you will also need to do the disk preparation, like partition your disks. And once all it is done, you will try to install Spark or Hadoop on top of it. And many of time, you will see that the installation will fail. Installation can fail for multiple reasons. It could fail because of some missing configuration. It could fail for some missing dependencies. It could fail for some disk errors. It could fail for some network issues. And you will fix those issues and retry. And maybe after multiple retries, you will be successfully able to install Spark or Hadoop on a bunch of machines. So the story does not end here. So once you have the cluster, you will submit your workloads. And then you need to start worrying about the upgrading your clusters for the security fixes, upgrading your clusters for the new version of the Spark or Hadoop or the dependent libraries. You need to worry about the scaling your cluster for increasing your increased workload in your analytical jobs. You need to worry about the high availability of the cluster. And then you realize that this is the moment when you want some virtualization and more repeatability in this process. So you will look for some virtualization solutions around it. And you will come across solutions like VM imaging solution, which you can take a snapshot of a running system and replay it as many number of times you want. And that solution will help you solve the problems of repeatability. You will be able to create clusters more easily, more repeatably, but it does not solve the problem of your network management. It does not solve the problem of scaling the clusters on demand. It does not solve the problems of patching those clusters for the upgrade or the high availability scenarios. Then you may also choose to try some public managed offerings provided by various cloud vendors. Like there are offerings from IBM Analytics Engine, which gives you a very good managed service offering, where you get the clusters on demand in few minutes. And there, or you can choose to go to Amazon EMR or Microsoft HCE Insights, which gives you the similar clusters and built on, some of them are built on SDP as a platform, but there you need to configure those clusters for your need. You need to customize your clusters with the libraries you need, and there you still need to worry about the scaling them based on your workload, because some of them don't provide the auto scaling features. And biggest problem there is that you are paying for the resources even if you are not using those clusters all the time. So as a data scientist, you just want to run your analytical workloads and don't worry about your provisioning infrastructures, and you don't want to pay for the time you are not using those clusters. So as a data scientist, you just want to sit in front of a browser or may have some programmatic interface where you are working for a notebook server, which gives you kernels, or working against a Zeppelin notebook, and you write your Python code, R code, Scala code, and submit it on some system which manages your provisioning infrastructure, which manages your availability, high availability issues, and scale issues, and still you are not paying for the resources you don't want to pay. So before we go to the options, which are like good fit options for trying out serverless kind of a behavior, let me just go over like some of the options which others tried, we tried to make this happen. One of the first options is like we took some bare metals. We wrote a lot of Puppet and Chef recipes to provision that hardware, to prepare them, to install them. That worked really well initially, but with the change in the problem came arising like when there is a change in some dependency, or when there is a change in the operating system versions, or when there is a change in some dependency, that code basically breaks. And you will see that breakage normally in your production environment. So then you will fix it and then prepare your recipes again. Another options which people tried is like using something called as XCAT, which is like the cloud administration toolkit. It really worked well for the scenarios where your system administrators were managing your systems, because that XCAT toolkit is very popular among the system administrators, but not so popular with the developer community because of its some proprietary imaging solutions which it builds. Like you get a system, you take a golden image of that system and replay it as number of any times. And because of its not popularity, that solution didn't went well. And then many people tried the solutions around which cloud specific images, like many of the cloud vendors have support of building image of a system, and you use that image to create more such VMs around it and have your clusters ready. That works well if you are on a single cloud provider, but if you are on both on-prem business and cloud, that solution might not be a right fit for you unless you have a solution which takes care of you, something like Cloudbreak, which does that for you. And another problem with this solution is that this is very specific to VMs. And if you want to work with bare metals, many of these specific image solutions does not work with bare metals. So Based on those experiments and based on learnings, we came up with some guiding principles which you could use if you want to have serverless offerings in your environment. So you are looking for repeatability. You want to make sure that you have less failures when you install your clusters or you configure your clusters. You are looking for those clusters to be up in few minutes and don't wait for longer time. And you also want to be sure that you don't need to keep upgrading your provisioning code, and you don't want to maintain that code, and that code should basically work for changing operating system versions, changing libraries. And at the same moment, you also get very good performance out of it, equivalent to the bare metals. And it should not be that there is a lot of overhead because of the virtualization being there. And you also need to make sure that you are using open source tools and code out there, and you are not writing your own proprietary code, so that you are not technology locked down. And you will also want to make sure that you are writing code which is cloud agnostic, which works on most of the cloud vendors, and as well as on your on-prem systems. So then we also start exploring on the sides of Docker containers. Like 4.5 years back, when I tried my first Docker run command, it was like a magic for me. Like in milliseconds, entire system was ready for me to be consumed. And I was really amazed by that. And containers bring a lot of good things around your system, but you need to be cautious when you start using containers for the first time. People usually make mistake of thinking them as a replacement for VMs, which is it not. So what are containers? Basically, containers are basically a group of processes running in their own user namespace, governed by some resource limits. Okay, so you think them as a group of processes running in an isolated environment. Whereas in case of VMs, they come with their own operating system and the kernel libraries, whereas in the case of containers, they share the kernel, and you just package your binaries in a container image and use them. Okay, and so what containers bring? So this, like, you can, as a data scientist, if you want to have that serverless Spark offering in your environment, you can build the solution around containers. What containers will provide you better repeatability. It will provide you the application portability, like you will build your images on your dev, and the same Docker images are can be ported to your QA environment or your production environment, and they will work. And it improves your development cycles, like you can have a pipeline very easily built around containers, and so that once you check in your code, and it is available for your production very fast. And it reduces the ops activities, because containers take care of like your system being rebooted, coming up, and you need very less number of operation people to manage your production workloads. And it also improves the infrastructure utilization, because you can build your resource capabilities around containers, so you get more utilization of your existing hardware. And because they are very lightweight and not virtualization is not consuming so much overhead on top of containers, so you get better utilization of your machines, underlying machines. But with containers being there, there is still a lot of effort you need to put in to make them as a serverless offering for you, maybe. Okay? You still need to manage your hardware. You need to get the right hardware. You need to have Docker daemons installed on your hardware. You would also need to consider using maybe a private registry kind of a solution, where you are storing your Docker images if you don't want to store it on the public Docker hub. So you need to plan for that and have them in your system. You will still need to manage the isolation, since you will be having the containers which are like from multiple clusters sharing the same machine resources. And you need to make sure that you don't run into the busy, noisy neighbor problems. So you need to make sure that you give the right CPU, right memory to each container, so that you don't overcommit on the hardware. And you have network isolation also built for, let's say, if you are running multiple clusters on same bunch of machines, you don't want your containers of one cluster to talk to another cluster over unsecured network, right? So you need to have those network boundaries built yourself. Docker enables you to do that, but you still need to build orchestration around it. You will still need to manage your networks. Some years back, the Docker networking story was pretty poor, but it is now very good. Like 3-4 years back, you didn't have like one container talking to another container in a different machine. If you need to do that, you need to work with Open vSwitch or use some technologies like Weave, which helps you do all that stuff for you. Whereas now you have very good options of using Docker network command itself to have those network created, which can talk to containers across the machines wherever you want. And this Docker network command basically uses a key store like etcd or a console, which maintains the metadata about the network. And you need to be cautious here, like one caution here. If you are looking for a scale of, let's say, 50 to 100 machines, this works very well in the default settings. But if you want to scale beyond 100 machines, you need to fine-tune your Docker daemons, and you need to fine-tune your key store settings to work it well. If you don't do that, if you go by the default settings, you will see problems like your Docker run command taking 20 to 30 minutes to respond, whereas you expect them to be respond in a few milliseconds. So those are some learnings you can have. We have published a lot of blogs. I usually talk about this topic in detail. And if you are interested and if you want more discussion, you can reach out to me. So and after you have those hardware configured, you have your network configured, you need to build your images. Like Hadoop or Spark is considered to be a monolithic application. So you try to build the small images as much as possible, and which is very difficult to do to start with. You can start with having images like image for a master node, image for a data node, or image for an edge node, and some auxiliary images like for your LDAP, MySQL, or Ambari server, and KMS maybe. So, but you should try to have images at per service level. Let's say if you are in your cluster looking for Spark, you should have separate images for Spark. But this kind of solution also works. Like these images range in size of 1 GB each, and which works for well to start with, and you can improve further on those. So this is the network architecture if you want to run your containers on the bare metal machines or your VMs. This is how it will look like. They will be talking to you some of the network interfaces, and these will be how the containers will spin out. But what point I want to mention here is that the resource scheduling part of it. So if you want to make use of the resilience features of Hadoop by having the replication number control, like if you want to have your data replicated across 3 nodes, you may not want to spin all your containers on a one machine. So you need to build the resource management capabilities. So what happens if you build all your containers on one machine, that even if you turn the replication on Hadoop and you have all the containers running on one machine, it's of no use actually. So what happens if your machine goes down? Your entire cluster is down. So you need to make sure that you spread your containers across the machines to make use of the resilience which comes with Hadoop. So you need to write some intelligence to schedule those containers across machines, right? So after that, you still need to worry about the persistence. I have seen that people try to write their output inside the container, which is not a recommended thing to do. Your containers should be stateless containers, and whatever you want to write should be written on some persistence which gets mounted on the containers. And for the persistence, you could use host volumes, or you could use some network files storage attached to the host, and you put your data on them and don't write on the containers directly. You could do that. Many people do that. But you need to be very cautious, and you should be very clear that what you are writing to those containers. And the reason behind that is that when you those containers get restarted or they are rescheduled on some different host, the data which is written inside the containers is not persisted at all. So once you have managed all those things, you need to worry about, like, you need to now do a lot of stuff. You need to write some microservices to manage all that. So you will come up with some orchestrator layer, which is managing the volumes for you, which is managing the network for you, which is managing the IPs for you, which you need to prepare a Docker run command, which takes care of the volume mounts you want to do, which takes care of ports you want to expose on your containers, which takes care of the host names you want to give, which takes care of the network which you want to choose. So all that code you need to write, and this is how it will look like. So there will be one central orchestrator, which takes the requests for your create cluster from you as a data scientist. And that request basically takes care of coming up with a blueprint for your cluster, like what all services you are requesting in that create cluster command. Where should I schedule those containers on the bunch of machines? How much memory and CPU should I be giving? And what kind of networking policies I'm looking for this cluster request. So all that is done by some orchestrator layer, which comes up with the blueprint, and then it shares that blueprint with some deployer agents, which are running on each of those machines. So what that deployer agent does is that it knows how to work with Docker daemon. It runs that Docker daemon, and it brings the container up. And once those containers are up and running, you will start some services on those containers, like Ambari server, Ambari agent. And once the Ambari server and agent are up and running, your orchestrator will submit a blueprint install on them so that you have your HTTP cluster ready for you. So that's the steps involved if you want to go with your own container orchestrator, and if you don't want to work with Kubernetes kind of a system, which manages a lot of stuff which you are doing manually here for you. So before going to the Kubernetes details, there is another option, which is like emerging thing for various use cases, like a function as a service. So many cloud providers are providing you function as a service capabilities. Like there is AWS Lambda, there is IBM OpenWhisk, there is Microsoft Cloud Functions, there is Google Cloud Functions, which works very well for scenarios where you are looking for single node environment, or a single node Python environment, or a single node Spark. And when it comes to the Spark cluster domain, it's a different ball game, because then you will need to do a lot of stuff to have the entire Spark ecosystem built on those functions. To give you some examples, you will need to as a data scientist, you are used to have the Spark history server, and you're used to viewing the Spark master UI, which you will not get if you are running on cloud functions in a cluster mode. You need to write your own stuff to make that happen. Function as a service in their current implementation come with a lot of resource limitations, which you need to be aware of when you are running the Spark workload. So a typical function in any of those cloud providers will run only for 5 minutes. And if it is going beyond 5 minutes, it will be killed. And a typical function will get a memory of about 3 GB in the current design, and it will get a disk space of 512 MB, which is not what we expect for a typical Spark environment. In Spark, it is like totally memory hungry and the totally disk hungry thing. So you need to have multiple of those functions if you want to run your clustered Spark jobs. And then there is one point, like architecturally, Spark works on the directed acyclic graphs, which results into spinning of multiple stages of your application. And there are scenarios where you want to have data exchange from Spark's one stage to another, which won't be possible because one function cannot talk to another function. So you need to write a wrapper around it to have your data shuffled from one executor to another. So you need to write your own shuffle service here to make it happen. So those are some points for the functional service. There are a lot of efforts being made to make this happen, and because this gives you very good serverless capabilities, because you are only paying for the time your function is running, and you're not paying for anything else. So what's the other option? So then you can try running your Spark workloads on Kubernetes. So what is Kubernetes? Kubernetes is an open source container orchestrator. It's one of the very popular open source projects. There are like 23,000 plus stars on the Git repo for Kubernetes. It evolved from Google's usage of container and orchestration over past 10 years. And it's been one of the very widely adopted container orchestration. And there are options of Docker Swarm. There are options of Nomad. There are options of Mesos. Or you can choose to have something, your own orchestrator, which I explained in my previous slides. So what Kubernetes does, it basically does all the operations I explained, which you need to do to spin that cluster. So what are the various components in Kubernetes? So there are, on the worker node side of it, there are kubelets, which are the Kubernetes agents running on each of those nodes, which talk to some of the master components, which are like API server and the key store to store that metadata. And user work with the API server or the master components to submit their request, what they're looking for. And user could choose to do it via CLI, UI, or APIs. And Kubernetes then makes sure that it gets deployed using the kubelets on those machines. So Kubernetes has the concept of pods. So you can think a pod as a group of containers doing some logical work. And you can attach various types of volumes on Kubernetes pod. And you can work with the services concept in Kubernetes. So everything in Kubernetes, you can treat it as a resource. So you can have a resource of type pod. You can have a resource of type service. You can have a resource of type volume, which you can declare in a YML or a JSON file and submit it to Kubernetes to get it up and running. So what Kubernetes will make sure that your pods are always running. Even if your pod goes down, it will schedule the pod to some other host machine. If your entire host machine goes down, it will schedule all the pods on that host machine to some other machine. So it takes care of the resource allocation entirely for you. It provides you very good plugin supports for the volumes you want. You could choose to run on the host directories. You can choose to have network files storage, or you can also have the option of mounting your object storage as a POSIX file system in Kubernetes. So it comes up with a lot of capabilities which are required for running a Spark or running a Hadoop cluster kind of a thing in the containerized world on Kubernetes. And it also comes with the very additional features like logging, security models, and monitoring for your applications. Those are inbuilt functions which you can use in Kubernetes to monitor your containers, to have better security around your containers. Whereas in case of Docker, you need to write a lot of AppArmor profiles. You need to write seccomp or SC-Linux privileges, manage the access to your containers. So that is very easy to do in Kubernetes domain. Kubernetes also provides like some of the products which are very coming up now. There is a product called as Istio, which is being worked in collaboratively with IBM, Google, and many other vendors to provide you the capabilities like authentication, authorization access, service mesh, a service level load balancing capabilities, which you get out of the box. So your applications or your Spark don't need to worry about all those aspects. Kubernetes work and Istio will take care of it for you. So with Kubernetes, you will get a choice of using the Spark Cluster Manager. You can still run your Spark in standalone mode or with Yarn on Kubernetes. So with that, what you will get is that you will get a Spark masters and workers, which you can spin very fast. If you have the images ready, they will come in a few seconds. And you can have something called as a JKG and the kernels created, which associate with your Spark clusters. And as a data scientist, you work with those Jupyter gateways to submit your queries on the Spark clusters, which are running on Kubernetes. So that is one option for you. Another option which you can use is that you run Spark against the Kubernetes as a cluster manager. So Spark core will send all the requests for the new executors or delete executors to Kubernetes scheduler. And Kubernetes scheduler will basically start those executors and manage those executors for you. So, and Kubernetes scheduler provides you the capabilities like it has their own shuffle service built, so that if your executor dies on one machine, it gets scheduled on some other machine. Your data exchange is handled for you via that shuffle service. And it also has additional components or there are plans to provide history server for you, Spark master for you, and so that you get the same look and feel of using Spark on Kubernetes. So to conclude, what data scientists are looking for a serverless kind of offerings. And what Kubernetes enables you that you get your Spark clusters in few seconds, and you get the high availability features. You get the auto scaling features, which is a very interesting thing to do in the Kubernetes world. Let's say you have a scenario where you don't know how many executors your job needs to start with, right? And you want some monitoring tool to increase the number of executors on demand, which you can very easily do that using Kubernetes and Spark monitoring APIs. And if some cloud provider, as we are providing you some capabilities where you are only charged on a job basis, which you run on Kubernetes, and you are not paying for the extra resources anymore. So IBM, in its current version, provides you a lot of offerings which you can try out. Like IBM Watson brings together a lot of data management, data policy, data preparation, and the analysis capabilities in a common framework. And you can index, discover, control, and share your data with IBM Watson, and have it cataloged in the Watson knowledge catalog, and refine and prepare with the using data refinery. And you can use Watson Studio, which gives you notebooks and experience, a data science experience for you. And it's basically an environment, and the tools are all grouped together for you have a one-page landing as a data science experience, and you get the entire full stack end-to-end analytics offerings from IBM. So IBM also has analytics engine, which is the managed service offering, which provides you to build and deploy cluster in few minutes. And with the simplified user experience and scalability, we will manage for you. And it comes with the custom configuration features and scale on demand. And if you're looking for more details on the Kubernetes scheduler, I have published this design and discussions link. So there are a lot of design and discussions happening to improve this Kubernetes scheduler going forward. In the current version of Kubernetes scheduler, they support a certain number of executors only. We are planning to increase the more types of executors to be supported. And if you are looking for a Kubernetes cluster itself, for you to try it out, you can go to the IBM Cloud and provision a free cluster for you. It will be a small cluster, to start with, and then you can increase the number of nodes or expand the capacity if you want to on IBM Cloud. So that's all for my session. Thank you. Any questions? Yeah. Yeah. Yes. So I explained that in the last portion of my slide that you can use Kubernetes in two ways. Like you could use Kubernetes to run Spark in standalone cluster manager directly, which would mean that entire Spark cluster is running along with the standalone scheduler on Kubernetes. That is one option. And if you don't want the Spark master concept or worker concept anymore, you just want to have the executors for you, you can do the Spark submit directly on the Kubernetes API server, and which then creates the executors for you and manages those executors and have the shuffle service around it. So that is the Kubernetes scheduler part of it. But if you want to use other cluster managers on Kubernetes, that is also possible to do that. Yes? Yeah, so it's a total one big topic to be discussed. And to give you a high-level overview, if you are looking for closer integrations with the capabilities which Kubernetes and the logging and the kind of monitoring capabilities and kind of security features which Kubernetes brings in, and if you don't want the overhead of master daemon and your worker daemons running separately, if you just want to have your executors, then Kubernetes scheduler is one of the choice which you have. Whereas Yarn is still a production grade scheduler, which is recommended still because Kubernetes scheduler is pretty new. There is a lot of work happening. It needs to be stabilized. And then once it's stabilized, then you can use it. Yes?
What about hybrid deployments for Spark clusters, say, on-prem?
Right. Yeah, so we as the cloud providers are working on solutions around it, like using Kubernetes itself. So we'll have a Kubernetes cluster deployed on-prem. And some of the workloads can be pushed to your dedicated account on cloud, not on the public. You will not be sharing the infrastructure with others. You can have your own dedicated account with us, your dedicated machines, and the Kubernetes will itself should take care of it. So we are planning to have offerings built around it, like which gives you seamless experience of using on-prem and cloud. Yeah. If you have any more questions, I'll be around. If you want to get into details of containers, Kubernetes, running Spark or Hadoop, or have more questions, please reach out to me. Thank you.